Hello and welcome to the factoring video. Here we'd like to take a look at factoring a trinomial in its form ax squared plus bx plus c. Now we've already taken a look in section 6.3 on a special case method, but this method is a generalized method, always works. This method is also referred to, I've seen it referred to as the AC method. The author in this textbook uses it factor by grouping, which is technically, as you have seen or will see if you've done your reading already or reviewed through the textbook, that we are going to end up employing the factor by grouping method. So without further ado, let's just jump in and take a look. And again, this particular method, we use this in general to factor polynomials. So let's just take a look at 3x squared plus 7x plus 2. Okay. Now, the AC method comes about because we are going to take the A coefficient 3 and then we multiply it by the C coefficient 2. So let's just note that 3 times 2 is 6. All right. So we take A times C, we get 6, and now we ask the question, what are the factors of 6 that add up to the B coefficient? So what are the factors of the product AC that add up to the B coefficient? So if I have to write that down, what are the factors of A times C that add to B? To be or not to be? All right, so if we take a look at factors of 6, and I'm going to kind of follow a method that kind of goes like this. Well, 6 is 1 times 6. All right, and so we can take a look at these two factors and note that 1 times 6 does equal to 6. And now we ask the question, what about 1 plus 6? So notice that 1 plus 6, does that add to the 7? And we can easily see that right off the bat it does. So now what we do is we rewrite the middle term, the 7x, in terms of this factor and this factor. So we get 3x squared, so that's just coming straight down here. And now I'm going to use this factor, go plus x plus 6x. And again, notice that these two add up to the middle term and then go plus 2. Okay, so this is the trick. So the trick is multiplying A times C and then finding those factors that add up to B. And then step 2, rewrite the middle term in terms of these two factors. All right, and now we employ our factor by grouping once we rewrite. So we get 3x squared plus x plus, and then group the second two terms, 6x plus 2. So then we come to the first grouping and we ask, what's the greatest common factor? Again, we're right back to what we talked about all the way back in section, what was that, 6.1? Okay, so here we factor out the greatest common factor, so this is going to be an x, so I'm left with 3x plus 1. And over here, the greatest common factor is 2, so I'm left with 3x plus 1. Okay, and we've seen this before, so notice we have these two, so we can pull those out. So we get 3x plus 1 times, and then notice what's left over, x plus 2. And that gives us our solution. All right, so let's take a look at another example here. So we're taking a look at 10x squared plus 17x plus 3. Now let's just recall in section 6.3 method that we talked about in class as well. The video, we discussed it in class. Here when we had a trinomial in this form, we tried to say, can we rewrite the A term and the C terms as something quantity squared? So clearly 10 is not a perfect square, and neither is 3. So if this doesn't work, then we kind of jump over to this case. So here we take 10, multiply it by 3. So let's just notice I get 30. So now the question is, what are the factors of 30 that add up to 17? So again, we get 1 times 30. Okay, notice that this multiplies this to 30, but notice I don't get my sum of 17. And again, for completeness, I can do the negatives. So I get my positive 30 when I product, but notice when I add, I get negative 31. So my next step is to go to 2 times 15. Notice the progression here. So again, notice 2 times 15 multiplies out to 30. And if I add these, I get 2 plus 15. And notice that that does add to 17. So notice what we'll do now is we'll take these two and we're going to rewrite this in terms of the 2 and the 15. So 10x squared plus 2x plus 15x plus 3. And again, notice that this middle part, all right, we're just rewriting that middle part in terms of these two factors. So again, now we do our factor by grouping. So 10x squared plus 2x plus 15x plus 3. So I can hear the question. I think I can hear the question. The question is, does it matter if I go 2x plus 15 or can I go 15x plus 2x? And the answer is, I don't think it really matters. It doesn't really matter, I don't think. So feel free to pause the video and rewrite it and continue and see what you come up with. So here, the greatest common factor, I get a 2x. So here I get a 5x plus 1 plus, and then I factor out the greatest common factor here, which is going to be 3. So I get 5x plus 1. And again, 5x plus 1 is common, so I pull that out. And then notice I'm left with 2x plus 3. And there it is. All right, let's take a look now, do a little signage going on here. So let's take a look at 3m squared minus m minus 30. So again, I can't write the first term as something quantity squared, nor the 30 as something quantity squared. So I have to employ the AC method. So notice that 3 times negative 30 is negative 90. So let's just kind of march through this progression. So negative 90, so I get factors of 1 and 90. But since this is negative, notice that one of these has to be negative. So if I do a negative 1, I get my negative 90. But if I add these, I get 89, and that is not the middle term. So if I swap these two, again, same thing. I get my product of negative 90, but I get my sum as negative 89. So those two don't work. So what about 2 and 45? So again, you just kind of march down this progression. Again, let's just note that if the 2 is negative, when I add these, I get 43. And notice if the 45 is negative, when I add 2 and negative 45, I get negative 43. So that's not going to work. So now I go 3, and notice that 3 and 30. So again, if the 3 is negative, I add these two together, I get 27. That's not my middle term up top. And notice that if the 30 is negative, I get negative 27, and that still is not. Still doesn't work. So the next question is, let's see, does 4 divide into 90? I don't think so. Since 90 ends in a 0, we know that 5 divides into it. So here we get 5 and 18. So again, doing my quick check. If the 5 is negative, negative 5 times 18 is negative 90. But if I add, I get 13. If the 18 is negative, I get my negative 90 when I product. And if I add, I get negative 13, and that is not my middle term. So the next thing to try is 6, and 6 is a factor, clearly because 3 times 2 is 6. And notice here I get 15. Again, played the same game. I get a -6, so -6 times 15 is -90, but -6 plus 15 is 9. And if the 15 is negative, I get my -90 when I product, but -15 plus 6 gives me a -9. And notice that what I'm trying to get to is a -1. So 8's not going to work. What about 9? So I get 9 times 10. Okay, so 9 times 10. So if the 9 is negative, so this product gives me my -90, but if I add, I get a +1. But let's just observe that if I make 10 negative, the product is -90, but notice when I add, I finally hit pay dirt. Whew. And notice that this is the last one I can go to, because notice if I go 10 over here, I go back to 9, so then I start going back up this way. So I'm all done at this point in time. So this was the last set of 2 factors that I had to check. So now we can rewrite this as 3m squared plus 9m minus 10m minus 30. So group the first 2 terms together, so I get 3m squared plus 9m minus, let's not forget our sign change. Don't forget the sign change. In class, I didn't see the sign change. This is where you do the sign change. So here I get 10m plus 30. So factor out the greatest common factor here, so 3m. So I get m plus 3 minus, and here I get a 10, m plus 3. So again, factor out the m plus 3. So I'm left with 3m minus 10. Okay. Yeah, there's not much we can do. You just kind of got to work your way through all those factors to see if you hit pay dirt. And let's just recall, if you don't hit pay dirt, remember, if you do not hit the pay dirt, prime. Okay, ends up being prime if you do not hit pay dirt. All right, let's take a look at 15m cubed plus 24m squared plus 9m. Now remember, we're trying to factor polynomials that are in the form ax squared plus bx plus c. This is not in the form. But again, let's just note, we have to first factor out a common factor, our greatest common factor. So I'm not seeing anything, let's see, number-wise. Oh yes, number-wise, I'm seeing a 3. I can pull a 3. Notice if you pull the numbers out, it makes the numbers smaller. So that's one of the things we'd like to do, is deal with small numbers when we have to do our AC method. And also we can pull out an m. So here I get 5m squared plus 8m plus 9. Okay, so now we get to play the game of, let's see. Oop, wait a minute. Thank you for catching that. I appreciate it. All right, so I should have had a 3 there. Okay, so we got our 3m factored out. All right, so now we go 5 times 3, so we get 15. So now the question is, what are the factors of 15? Let me rewrite this. That add up to 8. So again, 1 and 15. I think we can agree right off the bat that is not going to work. So let's go, let's see, 2. What about, and the next one is 3 and 5. 2's not going to work. And notice that 3 times 5 is 15. 3 plus 5 is 8, so that one's going to work. So 3m, so I can write this as 5m squared plus 3m plus 5m plus 3. Okay. So now we're going to do our factor by grouping, but I'm going to introduce some square brackets here. So 3m, and now notice my square bracket. So group the first 2 terms together. So 5m squared plus 3m. Group the second terms together. So 5m plus 3 square bracket. Again, greatest common factor here, 3m. So let's see, what do we get here? An m. Yep, looks like we're only going to get an m here. So I get 5m plus 3. And notice we get plus, and there's no greatest common factor here, 5m plus 3. Okay, so notice I get a 5m plus 3 here and a 5m plus 3 here. So I get my 3m, bringing that down. So 5m plus 3. Okay, we got that one taken care of. Now we got to remember what number is imaginary right there that's not there but really is there that's not there. Let's remember there is that placeholder of a 1. So when you pulled that 5m plus 3, let's just note we actually have an m plus, and there's our 1. Okay, so we got to make sure we get that factored. Let's see, our last example here, I do believe this will be my last example, and we got to get our 2 variables in. So 2 variables, I know we don't like working with them, but we got them pretty much on a straightforward basis, I think. I don't know, you let me know, I'm sure you will. So 6x squared y plus 13xy minus 5y. Okay. So again, I'm noticing that as far as numbers are concerned, there is no common factor in the number. And as far as the letter is concerned, I've got a y, so I'm going to pull my y out, which leaves me with 16x squared plus 13x minus 5. So now we take the product of 6 and 5, and notice that we get negative 30. So we're back to playing the same game. So again, 1 and 30. So again, one of these has to be negative. So if the 1 is negative, I add them together, I get 29. If the 30 is negative, I add these together, I get minus 29. And notice that both of those do not add up to the 13. So come over here to 2 and 15. So let's just note that if the 2 is negative, I add these together. And notice that I get the 13, so I hit pay dirt. So negative 2 and 15 will work. So I'll come over here and rewrite as 6x squared minus 2x plus 15x minus 5. Now we do our grouping. So 6x squared minus 2x plus 15x minus 5. So the greatest common factor in the first grouping. So we're going to get what? 2x. And we're left with 3x minus 1. And over here we can factor a 5. And we're left with 3x minus 1. So again, bring our y down. So notice we have a 3x minus 1 and a 3x minus 1. So we can pull out the 3x minus 1. And notice that we're left with the 2x plus 5. And that is how we play this game. Okay, that's how we roll. All right, I hope this video helps. Again, in the warm-up, if there's any questions on this or any of these examples, please feel free to provide that information so that perhaps we can get this covered in class. So the next video is going to be on factoring binomials in the form a squared minus b squared or a cubed plus b cubed and a cubed minus b cubed in its pattern matching. And I'm hoping that the 6.3 pattern matching comes into play. All right. Thanks a lot. Bye.